Okay, a couple of quick announcements before we dive into today's notes. First of all, the original plan was for your final unit conversion assignment to be due today as a graded assignment. However, since I was not here this morning, and I know that there were a few people that had questions about those and tried to come in during collaboration, I'm going to push that due date back for you. So tomorrow at the beginning of class, you'll have about 5 to 10 minutes to ask questions on any problems you were confused on. So bring those ready to ask, and then I'll allow you to make corrections and turn in the final assignment on Wednesday. Now today we're going to be talking about statistics. Statistics are the collection, evaluation, and interpretation of data. This is really commonly used when you have a series of measurements to help check for what we call quality control. So if you're mass producing 1,000 pieces of something, you want them all to be the same. Statistics allow you to analyze and identify if there's some parts that don't meet your quality measures. Now, statistics come in 3 categories. We call central tendency, and if you learned about some statistics in middle school, like mean, median, mode, that's what you're used to thinking about. That marks where the center or the middle of a group of data is. Next up, we have what we call distribution, and that's how frequently different data occurs. A lot of like your bar graphs and histograms, or those bell curves we've talked about, those would fall under the distribution category. And lastly, you have variation, which is how spread out your data is. That could be like a range calculation where you're trying to figure out how far apart the largest and smallest values are, or a new one we're going to learn today called standard deviation, which measures how far data is from the middle. Now, you're going to notice that all of the calculations we go through today, you can find in your formula sheet. For example, mean is something you guys have calculated in middle school. That's just what you're used to thinking of for the average, where you add up all your data points and divide by the number of data points. But if you look at the formulas in your formula sheet, you might notice they look a little bit different. This is an example of what your mean formula would look like on the formula sheet. Now I want to point out a few things. You're going to notice that some of the letters and stuff they're using for variables don't seem familiar. It's because a lot of engineering and science formulas use the Greek alphabet instead of the Roman alphabet, which is what we use in our day-to-day lives. So if you see a formula and you're not sure what it means, most of the time it's going to give you definitions of each variable underneath. Remember that you get to use the formula sheet on every test and quiz we take. You're not expected to have all these memorized, but you do need to know how to use your resources. So if I break this formula down for mean, this variable right here, it's called mu, it means mean. This one, it looks kind of like an E, is your summation. It means you add everything together. Xi means all your individual data points, and capital N is the number of data points you have. So if you have a set of data, remember the steps. I would start by adding all those numbers together, and then I check how many values we have. In that case, that's 11. When I plug it into the formula, I take my summation, 243, divided by 11, to end up with a value of 22.09. Another way of measuring the middle of data would be what we call a mode. A mode is the most frequently occurring value. So that's the value that appears most often in your data. So if I've got a data set that looks like this, what I'm going to do is go through and look at what items appear multiple times. So the only number in this set that appears multiple times is 21. So 21 would be my mode. Now on occasion, you're going to get a set of data where you have multiple numbers that appear multiple times. For example, in this set, it's just the number 63 appearing twice. But in my second set, 63 appears twice and 59 appears twice. We call this bimodal because there's two, bi means two, there's two different modes. You can also have mode sets like this where you've got 3 numbers that appear multiple times. In this case, we call it multimodal. And you could end up with 4 modes, 5 modes, depending on how big your data is. So anything more that's 3 or more is considered multimodal. Now, if you have no numbers that appear multiple times, we just say that there is no mode. The last measure of central tendency is what we call the median. The median is the middle, the exact middle of a set of data. So if I have a random set I want to organize it from biggest to smallest. And then I count my total number of data points to find the middle. In this case, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. And so my middle would end up being this value right here, the 21. Now, sometimes you have an even number of data points, and so you don't have an exact middle. For example, in this data set, I've got 12 numbers, and so 21 and 23 appear as my middle. When I run into a situation like this, I take the mean of the two central numbers. So I'd add up 21 plus 23 and divide it by 2 and consider my median to be 22. Moving on to our next type of data, we've got what we call our distribution. So distribution is showing how often different values occurs, and the most common way of measuring this is with a chart called a histogram. Now you've made some histograms earlier this year. Remember that a histogram is a bar graph that shows how often or how frequently something happens. In this case, we're measuring the length of some sort of item, and we're measuring how often that length occurs. In a histogram, frequency always goes on the y-axis. In this scenario, we've got a set of data. So I first look how many data points appear from 1 to 5. And I've got 3 of them. Next up, I look at how many data points appear from 6 to 10. I've got 1, 2, 3, 4 data sets that appear, or data points that appear within there. And my final range is 11 to 15. I've got 2 data points that fall into that range. So notice I'm not graphing the value of each data point, but rather how many data points fall into the given range. The final type of statistic is what we call variation, where variation is how spread out your data is. And you're used to measuring variation with range. Range is the difference between the largest and smallest values. Remember, when you see difference, that means subtraction. So I would do the maximum value minus the minimum value. Or in this data set, that's 44 minus 3, which gives me a range of 41. This is the most common form of variation, or the most common way of measuring variation, but it's actually one that's not used by engineers all that often. The type that's used by engineers frequently is called standard deviation. And standard deviation is a bit more of a complicated measurement. The difference between range and standard deviation is that range compares the largest and smallest values, where standard deviation compares all the data values to the middle of the data. When you have a large number for standard deviation, that tells someone that you have a very big variety or a very wide spread in your data values. A small number for standard deviation, like close to 0 or close to 1, indicates that your data is located very close together. Now, if you initially look at the formula for standard deviation, looks a bit overwhelming, but you can break it down to individual things that you know. Oops, sorry about that. For example, you've got an exponent, so you're squaring something. You've got division occurring. You've got subtraction. You've got a square root. And so to help you remember, I've broken it down into some individual steps for you. The first thing we do when we find standard deviation is we calculate a mean. After that, you take each individual value and you square the difference. So what that means is you take the value minus the mean and square the difference. You have to repeat that step for every single data point. After you've done that for every data point, you add together all the squared differences. Then you divide by the number of data points and take the square root. So let's look at an example here. We've got a football coach that's trying to decide which of 2 running backs he should start this weekend. We need to calculate the average yards per carry, as well as the standard deviation for each player to help him make some sort of decision.